in the previous lesson, we have already briefly learned about client-server communication, the HTTP protocol that is used for client-server communication, and REST API. We have also set up a simple server using JSON server, which we can then connect to from our React application and fetch data or post data to. Now, how do we actually communicate with the server? Now, this is where we make use of fetch. Now, what is fetch? How is it useful for communicating with the server? And how do we actually make use of it within our React application? Let's examine that in a little more detail in this lecture and the exercises that follow this lecture. Now, if you are familiar with how a browser application communicates with the server, earlier we had access to XML HTTP request that was implemented in most browsers that enabled us to communicate with the server. Now, this is quite cumbersome and outdated already for modern day web applications, and hence we would rather prefer a more modern or a newer implementation of the communication protocols within our browser so that it can communicate with the server. Now, XML HTTP request has been successfully made use of by many JavaScript frameworks and libraries for communicating with the server. And indeed, that is still the go-to approach for communicating between your browser and the server. But there is a newer kid on the block. The Fetch API is proposed as a modern replacement for XML HTTP request. Now, it is quite new, and so some of the older or legacy browsers do not support it yet, but the newer browsers are all beginning to support the Fetch API as a part of the browser itself. Now, this provides an interface for fetching resources, including from across the network. That's indeed the purpose of Fetch. And Fetch provides a more powerful feature set and a more flexible feature set than what XML HTTP request provides. Now, many of the JavaScript frameworks earlier wrapped the XML HTTP request in their own code and made it more palatable for use within those JavaScript frameworks. So, for example, within Angular, React, or Backbone, jQuery, the jQuery AJAX method, for example, is all a wrapping of the XML HTTP request. Now, Fetch API inherently supports promise-based approach for communication. Now, we have already learned about promises in the previous lecture, and we have seen how promises provide a way for implementing asynchronous computation. So, Fetch supports promises inherently, and that is what makes it valuable for use in communicating with a server. Let's look at some of the salient features of Fetch and how we can make use of it in this lecture. Now, when you talk about Fetch, there are some abstractions that we need to be aware of. In Fetch, a request represents a resource request. And similarly, a response represents the response to the request that you send to the server. Now, the request and response are objects that you have access to and can manipulate that. Similarly, the headers object represents the request response headers. Now, you can query the headers, extract information, you can add headers to an outgoing request, you can extract headers from the incoming response and make use of them within your JavaScript code. In addition, the body itself is another object that is part of the Fetch API, and it provides methods relating to the body of the response or the request message. Now, you can declare the content type of the body, how the body should be handled. You can even put information into the body. You can extract information of the body and so on. And that is all supported through Fetch API. Now, how do we make use of the Fetch API? A simple usage of the Fetch API is within your JavaScript code, you simply say fetch and then supply the URL of the server that you want to access. So in this case, I am representing the URL as a base URL plus an extra part of the URL. This is exactly what I will use in the code in the exercise/. The base URL is configured with the http:// the address URL address for the server, and then the extension is the specific resource on the server that we are accessing. Now, once you issue this, now this will return a promise object. Now, when it returns a promise object, then on the promise object, you can apply a then to the promise object. So as you can see, you apply the then, and within the then, you get access to the response object. Now, once you get the access to the response object, this response object is the raw body in the response message. You can convert if you know that the response body contains data in JSON format, you can simply convert that by saying response.json, and then that'll give you the body in JSON format, and so it is more easy for you to process that within your JavaScript code. So that's one way. Then when you obtain that, then you can the response.json will return the response in JSON format, and then that will be passed into the next then that you can chain into the previous then. So as you saw, we can chain promises together, and that information returns in the form of a parameter called data here. Data is just, you can use any parameter name there, but I am using data as the parameter name because that's the data that I have obtained from the server, and then I'm simply logging the data to the console just to show what has been retrieved from the server. You can do additional processing on this data that you obtain from the server. Indeed, in the exercises, that is exactly what we will be doing with the incoming data in the response message. Now, sometimes when you encounter errors, then you provide the catch for catching the errors. In that case, you can catch the error and then deal with the error appropriately. In this example, I am simply logging the error to the console and then leaving it there. I'm not going beyond that point, but if you want to handle error in a more elaborate manner, then this is a place where you can implement the code to handle the error appropriately. Now, any request that you initiate like this will result in a GET request being sent to that URL endpoint. If you want to perform any other kind of HTTP request other than GET, then you can explicitly specify the method in a second parameter that you will supply to the fetch. The second parameter will be a JavaScript object with properties where you specify the details of what goes into the message. So, for example, if you are posting some data to a REST API endpoint in order to create a new object on the server side, then you could simply say fetch and then supply the REST API endpoint. Following that, within a JavaScript object, you can specify the method as post, for example. Then you can even specify the body of the outgoing request message. So in this case, I am taking a new comment, which is a JavaScript object. I am stringifying that and converting that into JSON and then putting it into the body of the outgoing request message. In addition, I can even configure the headers for this message by specifying the headers property in the JavaScript object there. And so here I'm specifying the content type as application JSON. And also I can specify credentials as same origin, meaning that you include credentials only when it is being sent to the same origin as specified in the URL about to the same server as specified. Now, credentials part, cross origin and same origin and so on, I will deal with that in the Node.js course, which is the last course in the specialization. For the moment, just accept that you have a parameter like that in there. There are more parameters, there are more properties that you can include in this object that you supply as the second parameter to the fetch call here. Now, when you send the post request, the server will then respond with a response message, and that response message can then be processed appropriately by using the then and then catch, as we see. When the data is posted to the server side, the server will respond back with a reply. The reply might actually contain a copy of the data that is posted. Now, this depends upon how you arrange your server side and what the server will send back in response to a post request. Now, if you are implementing the server, you have the full flexibility of implementing what the server will return in response to a post request. Typically, the post request will result in the server sending back a copy of the resource that has been created on the server side, if it is successfully done. If there is an error, then obviously an error message will be returned to the client side. How do you deal with errors? Now, with fetch, you have a specific way of dealing with errors. Now, when you send the fetch request, then in the then part of the message, now earlier we saw that in the then part of the message, you got the response and then you dealt with the response. Now, the response from the server side could be a true response with a status code between 200 and 299, which means that everything went very well on the server side. But if the status code is in 400 to 500 range or something outside the 200 to 300 range, then your server will simply send back the response message as such. But with fetch, you have to explicitly check the response message to see whether the status code is an acceptable status code, or is it the status code is indicating some error on the server side, and handle it appropriately. Now, fetch provides you with a method of doing this. What fetch does is, if the status code in the response message is within the normal limits, 200 to 299, then it will set a property called as OK on the response. And so you can check this response.OK to see if it is true or false. If it is true, then the response that you get is a valid response. And so you can simply return that response over to the next then that you chain into this sequence of there. Otherwise, so this is the otherwise part. If it is not, then you recognize that your status code is outside the normal range that you would consider a normal response from the server side. In that case, we will handle it with the else part. Here, you have to explicitly create an error like this here. So you're extracting from the response, you're saying response.status. Response.status contains the status code. So for example, if you receive 404, the else part should be executed because the response.OK will be set to false. So the else part will be executed, and there you will construct an error object as shown here. So you can extract the status text from the response and the status code from the response, and then construct an error message string as shown here, and then you can put that into the error object. You can even put the response into the error object if you want, and then throw the error there. When you throw the error, the catch that you implement later on will catch this error and then deal with it appropriately. So that's how you would handle the response from the server side. Now, if the server explicitly, or if in communicating with the server, you experience an error, so which means that you never even managed to communicate with the server, in that case, fetch will generate an error response, and that is handled by giving a second callback function to the then. Promises allow you to give two callback functions as parameters to the then. The first callback function will be used when the promise resolves correctly. The second callback function will be used when the promise is rejected. So the error part is where the rejection of the promise is handled. So if it is rejected, then you will create the error message from the error message and then throw an error at that point. So that's another way of handling errors that are caused. So this is fully your responsibility. So this part of the code is something that you implement when you use fetch. Now, some people that use other libraries, I will talk about them a little bit later, some of the other libraries have a much better way of dealing with this. And so some people prefer not to use fetch, but instead use some of the other libraries like Axios. I'll briefly mention that at the end of this lecture. Now, and then after that, you can carry on with the chain of thens, which will handle the response accordingly as per what you choose to do with the data. And then, of course, you have the catch that deals with the error message accordingly. If you are using fetch on browsers that don't have fetch already built in, then you can use a fetch polyfill that will be inserted. Now, cross-fetch is an NPM package that makes use of a fetch polyfill in situations where fetch is not inherently part of the browser implementation. So cross-fetch provides support for fetch. Now, if you can use cross-fetch even on the server side for doing fetch. So even within your Node.js application, if you want to contact another server, you can use fetch also. And cross-fetch supports that. And so that's why in our application, we may install cross-fetch. And then this cross-fetch, if your browser doesn't have the fetch built into it, then it'll resort to using the WhatWG fetch polyfill. The WhatWG fetch polyfill is a implementation of the fetch protocol or the fetch API that can be put into browsers that don't have native support for fetch. And similarly, the cross-fetch will resort to using another NPM package called Node Fetch, which is used if you're using this in a Node application. Now, in our case, we are using it in our React application, and the Create React app automatically includes cross-fetch into our React application, so you don't need to explicitly do anything for using that. But if you are using cross-fetch, then within your application where you use fetch, you may simply import fetch like this from cross-fetch into that JavaScript module and then make use of fetch just like you use fetch otherwise, as we have seen in the previous slides. Now, as I briefly mentioned earlier, some people dislike fetch and feel that fetch is too low-level alternative. But then when you look at XML HTTP request, fetch seems like a significant improvement from XML HTTP request way of doing things. But then people had already figured out by wrapping XML HTTP request in their own code so that they give a better API for app developers. So people, if you search the internet, people will often complain that fetch is too low level for them. And then they prefer to use other libraries like Axios or even another one called Super Agent. So if you search for React and communicating with the server, you will also hear people talking about Axios and Super Agent. Axios also uses wraps XML HTTP request and then exports a better API for use within your React application. Now, the Axios API seems better than Fetch API, or rather, at least Axios gives a much higher level API than what Fetch gives. And so some people prefer to use that instead of Fetch. If you choose to do so, you can do so. Axios also supports things like automatically adding credentials and also adding interceptors. We will talk about interceptors in the Node.js course, where we will see the reason for using them. And so I will defer that discussion to that point. So if you don't like Fetch, you can then go and fetch Axios or Super Agent and use them in place of Fetch. So whatever satisfies your needs. Now, in my course, I will use Fetch as the approach because Fetch also works very well with React Native, as you will see in the next course. So that's why I deferred to using Fetch for communicating with the server. With this quick understanding of Fetch, let's move on to the exercises where we will see how we can make use of Fetch to communicate with the JSON server that we have set up in the previous lesson.